Okay, 3 random pages of my refrigeration book. Let's go. Magnetism. All magnets have a north pole and a south pole. Like poles repel each other, try to move apart. Unlike poles attract. The attraction and repulsion of magnetic poles is shown in the figure, which you guys can't see. There are lines of magnetic force connecting the north and south poles of a magnet. These lines of force are called magnetic flux. The space in which a magnetic force is operating is called a magnetic field. Magnetic flux will flow through most substances. It is not stopped by glass, mica, wood, air, or any other material used for electrical insulation. Some substances, particularly soft iron, are better conductors of magnetic flux than other substances. This is why certain parts of electric motors and generators are made of soft iron. Instruments can be shielded from a magnetic field by placing them inside a soft iron case. Because soft iron is a good conductor of magnetic flux, the magnetic field will pass around the instrument inside the soft iron case and not through it. Permanent and induced magnetism. Permanent magnets are usually made of hardened steel. Once magnetized, they remain magnetized. Some patented alloys of iron, aluminum, nickel, and cobalt make strong permanent magnets. Magnetic lines, flux, tend to become as short as possible. This shortening force has many industrial applications. Permanent magnets are used in some controls to provide a snap action for electrical contacts. They are also used in small control motors. Any material capable of being magnetized becomes a magnet if it is placed in a magnetic field. This is called induced magnetism. For example, if a piece of soft iron, which is a good magnetic conductor, is placed in a magnetic field, then the piece of soft iron becomes magnetized. Induced magnetism forms the basis for how an electromagnet is constructed. Electromagnetism. If an electric current is passed through a conductor, the conductor becomes surrounded by a magnetic field. If the current is turned off, the magnetic field will disappear. If the conductor is wound around a piece of soft iron and current is passed through the conductor, the soft iron becomes a magnet. This is an example of induced magnetism. Turning off the current, opening the circuit, stops the magnetic effect. This magnetic effect caused by current is called electromagnetism. Magnets formed in this manner are called electromagnets. The iron part is called the core. The current-carrying conductor is called the winding. Electromagnets are used in motors, relays, solenoids, and in many other electromagnetic applications. Screw compressor design variations. Screw compressors are often used in large capacity systems ranging from 20 to 300 tons. Open drive compressors, like the one shown in this figure, are most often used with ammonia and other high pressure applications such as chillers. Hermetic screw compressors, like the one shown, are used with hollow carbon refrigerants. Many screw compressors operate with oil injection. The oil seals the clearance between the rotors and cylinder to prevent refrigerant leakage. It also helps cool the compressor. The efficiency of these compressors is quite high. One type of screw compressor uses one main rotor rather than two. This type of compressor is called a single screw compressor. In a single screw compressor, the main rotor meshes with two star-shaped rotors, which are driven by the main rotor. The basic operating principles of a single screw compressor are the same as those of other screw compressors. Centrifugal compressors. Centrifugal compressors are designed for use with large capacity systems ranging in size from 50 to 5,000 ton. In this type of compressor, the vapor is fed into a casing, stator, near the center of the compressor. A disc with radial blades, impeller, spins rapidly in this casing. The vapor is flung outward in the casing, piling on top of the vapor ahead of it, causing slight compression. The force that throws the vapor outward is called centrifugal force. Because the compressors rely on centrifugal force to compress the refrigerant, their efficiency increases with speed. Therefore, the compressors are designed to operate at high speeds. The pressure gained is small, so multiple impellers may be used in series. This creates greater pressure difference and pumps a sufficient volume of vapor. Construction. The centrifugal compressor has the advantage of simplicity. There are no valves or pistons and cylinders. The only wearing parts are the main bearings. The stator of a centrifugal compressor is the casing in which the impeller rotates. The stator may be bolted to the compressor housing, or it may be an integral part of the housing. The stator is a volute design, meaning that it is spiral-shaped. It can be clearly seen that the stator, in figure, is wider and taller at the top of the compressor than at the bottom. In fact, the width and height of the casing gradually changes along the entire length of its perimeter. The casing, stator, also holds the main bearings, oil pressure pump, and the vapor intake and exhaust ports. To check the system for leaks, it is charged with nitrogen or helium in accordance with the manufacturer's instructions. Soapy water is applied to potential leak points, such as welded joints, sight glasses, and diaphragm valves. If bubbles form, a leak is indicated. After the leak test, the nitrogen or helium is removed. Any necessary repairs are made, and the system is purged. Proper purging is necessary to remove any non-condensables from the refrigerant absorber solution. Maintenance of lithium bromide absorption chillers. Once air enters a lithium bromide system, the lithium bromide solution becomes highly corrosive. The damage caused by corrosive solution can make it very difficult to recondition a failing system. Every effort should be made to prevent air from entering the system and to keep the lithium bromide solution properly balanced and free of contaminants. The manufacturer's maintenance recommendations must be closely followed. Servicing and installing humidifiers. Humidifier capacity should be based on the size of the space being conditioned and the design conditions in that space. The humidifier must be able to deliver adequate moisture to the air under all operational conditions. Once selected, humidifiers must be carefully installed. Mount the water reservoir so it is level in all directions. Use a spirit level to check the angle. The water feed line should be tapped into a cold water line. This is done in the same manner as an ice cube maker line. Okay. I'm just looking. Something called a saddle valve and something called a fill valve. And there's the humidifier, overflow drain. Okay. We are learning, believe it or not. We are getting smarter. Okay, thanks for tuning in.